it wants me to find out what is called a turning point of a function, okay? So it gives me this function here, question 7. And what question 7 wants me to do is it wants me to find the turning point of this function, and it wants me to tell whether it's a maximum or a minimum. Now let me tell you what a max and min means. A max is the top where it curves up and back down again. That's what's called a maximum turning point. And a minimum turning point is the one where it's on the bottom and then it's on its way back up again. Does that make sense? Yeah. Maximum and minimum. Okay, you've drawn these before. Now, what you can do next is, you don't have to draw the graphs, okay, but I'm just using the graphs to show you where the answers are going to be. So, if you were to put this into your calculator, okay, pay attention. If you were to put this into your calculator, and it's x cubed minus 3x squared, what you do next, guys, is you enter in this into your calculator. Okay, now let me explain how this will work. Take a rough guess, left or right of the center. Let's go from -6 all the way to +6. Now look what happens here, guys. Okay, look at the points. The first point is -6, 266. Where is that located on this graph? It's located all the way down here somewhere, long gone. Keep scrolling up. -4, 72 is still out of range. Then you have -323 around here. Okay. So just let me continue. You have -323. Then you have -22. Where's -22? Is located here. And then you have -19 located there. And what happens after -19? Goes down again. And you can see 0,4. -19 is the biggest y value. Does everybody notice that? Look at all the y values. This column here. Look at the largest y value being 9. And then it goes back down again. And when does it reach its bottom value and then start coming back up again? Find out. 3 minus 23. And then 4 minus 16 is above 3 minus 23. So that's when it starts to go up again. And then it just keeps on going up forever after that. Okay, now what we're asked to do in these ones is we have to find the location of these without drawing your diagram and without doing any of that. So before we do that, we know that the answer is going to be, just taking it down from the calculator at the moment using the graph. Okay, the answer is going to be -19. And what's the other one then? 3 was a -23. Okay, so 3 minus 23. Now, let's find a way of doing that without the graph. Okay, step 1. We're in the differentiation section of the course. We haven't differentiated yet. Okay, differentiate. Now, what does differentiation do? It gives you the equation of what? The slope. Gives you the equation of the slope. Does everybody agree that the derivative of this is 3x squared minus 6x, the minus 9x turns to -9, the 4 turns to a 0. Does everybody agree with this here? Yeah. Now, let me tell you what this actually means. Does everybody see the value x equals 1? X equals 1 is this point here. Does everybody see that? Yeah. Is the curve on its way up or its way down there? Yeah. It's on its way down, okay? Now, guess what happens when I replace x equals 1 into this equation? When I put x equals 1 into this equation, I am now going to get a negative slope. It's going to be 3, oh sorry, that's a -9. It's going to be 3 minus 6 minus 9, which is -15. That's going to be -12. At this point, your slope is facing downwards at a -12 slope. Does that make sense? Now, yeah. The calculator that time. Just the table function to do the drawing. The 1. I'm just explaining what the first derivative means.
No, I get that, but what did you put in the calculator to get the points?
The table function. Remember table 3? Remember the graphs where we used to draw the graphs? That's what I put in. Mode 3. Okay. Now lads, excuse me. Let's try another one, okay? Does everybody see the point where it's 5? 5 something. Is it on its way up or its way down when it's at 5? It's on its way up. So if you were to substitute in 5, what would happen? If you were to substitute in 5, you're expecting a plus number. Let's find out if that's the case. 3 times 5 squared, 75, minus 6 times 5, minus 9. So it's going to be 75 minus 30 minus 9. And that will give you 75 minus 39, which is 36. So does that make sense? It's a slope of plus 36 at that point. Alright, let's stop there. The next part after that, guys, is you'll notice is that at the top, at the very top where the turning points take place, there is no slope. The slope is now 0 because it's not going up or down. So what that means is that the slope has to be 0 at this point. So what we do is we say our slope equals 0. So we have 3x squared minus 6x minus 9 equals 0. Sorry, excuse me a minute. What we have here, guys, is we divide by 3. Okay? And when we divide by 3, we get x squared minus 2x minus 3 equals 0. You solve it. This is a quadratic, right? To solve a quadratic, you always have an x squared, you always have an x number, and you always have an equal 0. You do what's called the reference number. What's the reference number for this, Sean? Reference number?
Minus 3.
Minus 3. So what we get is minus 3 breaks up into two numbers. What are they?
Minus 1 and 2.
Minus 3 plus 1. And it's x minus 3, x plus 1 equals 0, x equals 3, x equals minus 1. What you know about these 2 points? That's where x equals minus 1, isn't it? And the other one is where x is equal to 3. So you found the x values, but what you haven't found is the y values. So that's where your table function comes in really handy. All you have to do then is go back to your table function, and you go to your table function, and what you say is that, oh, that's 3 minus 23, and the other one is minus 1, 9. So minus 1, 9, 3, 23. Now, what's going to ask you next is, you have to prove if it's a maximum or a minimum, okay? So you're going to have to prove if it's a maximum or a minimum. So here's what you do. You do the second derivative. So what's the second derivative? Can anybody tell me? If that's the first derivative, what's the second derivative? 6x minus 6, okay? Now, what you do with 6x minus 6 is, you plug in your two x values, okay? Now, if the second derivative is smaller than 0, it's a maximum. If your second derivative is bigger than 0, it's a minimum. Okay, so that's the learning off part. That actually makes no sense. That's fairly random, but it works every time. Okay, so what happens when we plug in x equals minus 1? It's going to be 6 times minus 1 minus 6, and what is that? Minus 12. Minus 12 is it bigger than 0 or smaller than 0? Sorry? And if it's smaller, it's called a maximum, okay? And if it's bigger, it's a minimum. So this time replace x with what number? X is going to get replaced with 3 this time. 6 times 3 minus 6, 12 is greater than 0, therefore it's a maximum, okay? John, the 12 greater than 0 matches the, the 12 greater than 0 is the minimum, because greater than 0 is the minimum, okay? So this one here is the min, that is the point 3 minus 23, and the maximum is the 1 minus 9. Is that right? I'll do one more of them, okay, and this other one will make things a lot easier. So, what you're always going to do in these questions, you don't even draw it half the time, okay? So there's two things to learn off when you're talking about maximum and minimum. You're given an equation. The first thing you do is you always do your slope equals 0. Why does your slope equal 0 again? Because at the maximum and the minimum, the slope is going directly to the right. This means it has a slope of 0. That's why the first thing you do is always put down slope equals 0. Do I dx equals 0. You figure it out, okay? Once you do that, there's a test to see which one's the maximum and which one's the minimum. The test is the second derivative is bigger than 0, it's the min. If the second derivative is smaller than 0, it's the max. And that's the procedure you do for every single question. Okay? So let's just put this procedure here to the left and follow it for every question. Okay? So what's step 1, Sean? Step 1 now. What does dy dx mean?
Differentiate.
So differentiate question 9. And what you get?
Y equals
Dy dx equals
9x squared.
3 by 2.
Sorry, 6x squared.
6x squared. 2 by minus 9. 2 by minus 9. Minus 18x.
Minus 18x.
Differentiate 12x
Plus 12.
plus 12 equal to 0. Now, that's your derivative, okay? That's the answer for your first derivative. Okay? Just remember that. Now, let's solve the first derivative equal to 0, okay? Mick, is there any number you can divide all these by? 6, 18 and 12. 6. So 6 into 6x squared. X squared. 6 into 18x. Minus 3x. 6 into 12. 2. What type of equation is that?
Quadratic.
It's a quadratic, okay? How'd you solve a quadratic, Josh?
You find the reference number.
You find the reference number. How'd you get the reference number? See what the reference number is 2. What two numbers multiply to give you 2, but when you add them, they give you minus 3. Minus 2 minus 1. So x minus 2, x minus 1. And then how do you finish that?
X equals 2.
Yeah, x equals 2, and the other one? X equals 1. Okay, I consider that reasonably easy. Okay? The part after that, however, maybe not so much. So, what we got to do next is we got to figure out what is the points. Because it says what are the turning points. So you go to your calculator, and what you do with your calculator? Can anybody tell me? Dennis, what you do with the calculator? Mode, which one?
Oh, 3.
Table. What formula am I going to put in? It's up here. We're doing question 9.
Yeah, no.
So you put that formula in, the question 9 formula. And what two x values are we looking to find out? What are the two x values we require for this question right now? Sorry? 1 and 2. Okay? So, make sure you have 1 and 2 in your answer. Start out, I don't know, minus 2, go up to 5. 1 and 2 are def what? Well, what's in between minus 2 and 5? 1 and 2. You just have to make sure you get 1 and 2. See, when I go through these numbers, Dennis, I have to make sure that x is 1. See the way x is 1? And x is 2. You could. Yeah. Yeah, but it's still the same thing. You're looking for where x equals 1 and x equals 2. So, 1, 6 and 2, 5 are my points. 1, 6 and 2, 5. Now, before we begin, which one do you think is the minimum? Just taking a guess here. Take a wild guess. Which one do you think is the minimum? Which one's higher up? No. It's the second value that gives it its height. 6 is bigger than 5, so you're pretty much thinking you're the max, you're the min. Let's find out. There's a graph of what we would have. Here's the point 1, 6. There's the point 2, 5. You can clearly see that there is the max and that there is the min. However, in your leaving cert, you're required to do the second derivative and prove that it's bigger than 0. So, using our answer from earlier, what is the second derivative? Sean, you're on the second derivative. How do you get the second derivative?
It's you multiply 2 by 6.
Yeah, 12x.
12x.
Then here?
Minus 18.
Minus 18. Now, we have two values to try out. If we put in 1, what are we expecting? 1 is the So we're expecting an answer lower than 0. Let's see if that happens. It's going to be 12 times 1 minus 18 minus 6 is less than 0. It's the minimum. Oh, sorry, it's the maximum. Less than 0 is the maximum. It says it to the left, okay? So, then we got to try which one after that. 12 times 2 minus 18. 24 minus 18. 6. 6 is bigger than 0. That makes it the minimum. Okay, guys.